Okay, so this is the second part of this review handout. So um, I'm just going to kind of walk through this. So as we've talked before, the range is the y values of these points, and the domain is the x values. So when I look at this here, the y values go from -3 to 3. The y values here go from -4 to oh, forever this direction. It's just an arrow. Okay. Oh my gosh, that's not domain. Sorry for the highlighting of the wrong color. My domain, it goes starting at 1 and what did I do? Don't pay attention to the coloring. Okay, the range is the y values, and the y values, it goes from -1, it goes from 1 up. The domain is the x values, and it starts at -4 and goes this way. Do not pay attention to the coloring. Sorry about that. Okay, pay attention to this coloring. So, okay, I messed up again. Okay, so the domain goes from -3 to 3. My range starts at -4 and goes up to 3. Okay, it's not a function because if I do a vertical line test, it goes through it twice. Okay, the domain is, it starts at 2 and goes this way forever. Okay, now I'm going to do the coloring correct. Okay, the range, the lowest the y value is at 2, and then it goes up because of that arrow there. So my range is, it starts at 2 and goes up. I mean, it doesn't start at 2, but the lowest it goes to is 2. Okay. This is easy because the arrows at both ends means the domain is all real numbers, and our range is all real numbers. Okay, that's an easy one. Okay, so the domain, it goes in both directions in the x. So my domain is all real numbers, but our range is restricted. Y has to be greater than -5. And yes, these are all functions, because if I draw a vertical line through all these, it only cuts through once. Okay, now this is important. They want you to draw the inverse function. So I think it's super helpful to draw the line y equals x. And then the other thing is, find points that are on the graph. So let me start off from scratch here without the answer already being shown. Okay, so okay, so pick some points that are on this graph. This is 2, sorry, -2, comma 2, right? So, comma -2. So we can tell it's on the orange line, so it's going to use that same point. This here is 2, comma 0. So on our inverse function, it's going to be on 0, comma 2. And so it's going to go from this line to this line. And then let's pick some other point. So notice this arrow hits the orange line, so this is going to go this way forever. And notice it looks symmetrical on the orange line. Okay, so my original line was like this, and then the arrow goes forever in that direction, right? So my new line, it starts here and then goes this way. And notice it looks symmetrical. I can do it like this, and you can see it looks symmetrical. Okay. Once again, use the points to help you. This is 2, negative 2, 2, negative 2. So I'm going to switch the x and y values. So I need to put a point at negative 2, 2. Negative 2, 2. Negative 2, 2. Okay. And I need more points to help me figure out this out. This point here of the original line is negative 2, 0. So I'm going to do 0, negative 2. And so now I've got 2 points to help me draw my line. So this is going to go this way. And once again, if you're drawing your graph, tilt it so you can look at it from the line y equals x. And you can visually see if you've done it correctly, if it looks symmetrical on both sides of the orange line. Okay, once again, this point here is 4, 0. So I need to do 0, 4. 0, 4. Let's get another point here. 3, 1. So this is 3, 1. So I'm going to have to do 1, 3. 1, 3. Okay, let's do, this is 0, 2. So I'm going to do 2, 0. And then that should be enough to give me the idea. Then I'm going to connect these 3 dots, looking like that. The original one I'm drawing here, I'm highlighting in blue. Okay. So, okay. So the domain of the, let's see, let's call this the original function. X is greater than negative 2. Y is greater than negative 2. X is less than 2. The range is y is greater than negative 2. And notice I'm putting the little equal sign underneath because it's a solid dot. Here we have a hole, so there's no line underneath the inequality. Okay, we're looking at the blue graph. I'm just going to highlight this blue because so you know which domain and range I'm giving here. Okay, so here x is less than 4, less than or equal to 4, and the range is y is greater than 0. Greater than or equal to 0. Okay. Next question. Okay. Show that g of f of x is this. So g of f of x, you're going to rewrite this like this. Oops. Okay. So we know f of x is this stuff right there. So I'm going to replace f of x with x plus 3 over 4. So I've got g of this red stuff, and that's what we need to plug this red stuff into function g. So we've got this here. So I'm going to put this red stuff instead of x, because we know g of, I'm just going to put happy face, right? G of happy face is equal to 8 times happy face plus 5, right? That's what we have here. G of happy face equals 8 plus happy face plus 5. But instead of happy face, I'm going to replace happy face with this red thing. So x plus 3 over 4. So I've got so 8 plus the red stuff, 8 times the red stuff plus 5. So we can simplify this because 8 goes into 4 twice. And then I can do distributive property. I get 2x plus 6 when I do distributive property. And now I can simplify this, and I get 2x plus 11. Okay? And now I have shown that this is what we get. Okay, now we want to find the inverse of this. So we know that our function here is y equals 2x plus 11. Okay, so if we're trying to find the inverse function, this little negative thing is we want to find the inverse function. So the very first thing we do is we switch the x and y. Okay, so I'm going to switch the x and the y, so now I'm going to have x equals 2y plus 11. We're going to switch the x and the y. And so now we've got, I can rewrite, and then we solve for y. So now we're going to solve for y. So I'm going to subtract 11 on both sides. And then I've got x minus 11 equals 2y. And now I can divide both sides by 2. And then I get y equals x minus 11 over 2. And so now I can say that g of f inverse is equal to x minus 11 over 2. You may want to replay or pause or play it slower if you need to, or if you totally get this part and you're waiting for the next part, you can play it extra fast. You should be able to change the speed on YouTube. Okay, given that the inverse of a equals 4, find the value of a. So we're going to take this function, and instead of x, I've got a. So so I've got a minus 11 over 2. Instead of x, I've got a, and we know that this is equal to 4. So now I can multiply both sides by 2, and then I get a minus 11 equals 8. And then I can add 11 on both sides, and I get a is 19. Okay, question 7. Find the range. Okay, so we know our domain is range of the original function. Okay, so we know our domain is this. So if I plug in -7 in here, we're going to get 2 minus 12 over -7 plus 5. And we get 2 minus 12 over -2. So we're going to end up with 2 plus 6, and that gives me 8. Okay. So when x is I don't know if my key is right. Let's type this into my calculator. Clear. Okay. 2 minus 12 divided by parentheses x plus 5, close parentheses. And if I graph that, okay, so for A, forget about what you just did here. For A, my range, let's just draw a picture of the graph here just so you can see what's happening. Okay, so for my range is x is not equal to -5. What does that mean? So when we look at this formula, we know that x can't be -5 because -5 plus 5 would give me a 0 in the denominator. Okay. Okay. Find the inverse function. So my inverse function, so remember, if we have y equals 2 minus 12 over x minus 5, the first thing we're going to do is switch x and y. So now I have x equals 2 minus 12 over y minus 5. Okay, so we can subtract 2 on both sides. And then I get x minus 2 equals -12 over y minus 5. I could, now I'm going to do a little trick that I want you to, if I've got a over b equals, I'm going to write it like this. I have c equals a over b. That's kind of like what we have here. We've got this thing equal to this thing divided by this thing. Think of that as c, a, and b. I could write this over 1. I could cross multiply and say a times 1 equals c times b. And then I could divide both sides by c. And then I would have a over c equals b. What I'm doing is I'm going to switch these guys here, and it's going to give me the same sort of thing. So I would have y minus 5 equals -12 over x minus 2. And wait, did I copy this wrong? It should be plus 5. Sorry. Okay. So, almost done with finding my inverse function. We need to subtract 5 on both sides. And I get y equals -5 minus 12 over x minus 2. Okay, we're trying to find the value of when we plug in 0 into this function. So if I'm going to plug in 0 in place of x, then we get negative 5 minus 12 over 0. And then we get negative 5 minus 12 over negative 2. So we get negative 5 plus 6, which equals 1. Okay, next question. Last page. Okay. So, we're trying to find a f of x. Okay, so we know f of x is negative 2 parentheses x plus 3, right? And now I'm going to take this and plug it into here. It might be easier to think of this as f of happy face equals negative 2 times happy face plus 3, right? So instead of happy face, I'm going to put this stuff here. So I'm going to have negative 2 times the happy face stuff plus 3. So I'm going to put this in here, negative 2x plus 3 here. Okay. So now let's do distributive property with this negative 2 first. So I've got negative 2 times negative 6x minus 6 and then plus 3. Okay. Negative 6x minus 3. Okay, now I can do distributive property with, oh, what did I do wrong? That's negative 2. Oops. Okay. Now I can do distributive property with the negative 2. Negative 2 times negative 2x, that's going to give me negative 4x. Negative 2 times negative 3 is going to give me positive 6. Okay. Here we have f of g of x. So f of, and g is x minus 1 over 5. Right? So now I'm going to plug in this value here in place of happy face. So now I've got this is equal to negative 2 times happy face, or red circle, x minus 1 over 5. Okay. And then I do distributive property with that negative 2. So I get negative 2x plus 2 over 5, and then negative 2 times 3 gives me negative 6. Okay. Last one here, g of f of x. Okay, so f of x is negative 2 parentheses x plus 3. And now I'm going to replace this red circle stuff right there. So I'm going to have this is equal to the red circle stuff minus 1 over 5 using this function. Red circle minus 1 over 5. What is the red circle? Negative 2 parentheses x plus 3. Okay. And Um, so we end up with negative 2x minus 6 minus 1 over 5. And this is equal to negative 2x minus 7 over 5. Okay, oh my gosh, we have to figure this out here. So if I've got y equals negative 2x plus 3, then we switch the x with the y and y with the x. Okay, now I can do distributive property with the x, or let's just divide both sides by negative 2. And then I get x over negative 2 equals y plus 3. And then now let's subtract 3 on both sides. And then I get x over 2 minus 3 equals y. So I can say, don't pay attention to that too. So we can say our inverse function is equal to negative x over 2 minus 3. Okay, inverse of g of x. Okay, so we know we have y equals x minus 1 over 5, right? So we're going to change the y into an x and the x into a y. Okay, multiply both sides by 5. So we have 5x equals y minus 1. And then we can add 1 on both sides, and I get 5x plus 1 equals y. And so my inverse function, this is g, is equal to 5x plus 1. Okay. And lastly, we've got this function. Jen is working with her function machine. She has 2 machines shown on the right. She wants to put them in order. So she wants so that the output of the first becomes the input of the second. She wants to begin with the input of 6. In what order does she need to put them in order for the final output to be 11? Okay, so it's either f of g of x, or it's going to be g of f of x. Okay, and the input is going to be 6, and the output should be 11. So let's try this one or this one. And the input is going to be 6. So if I plug 6 into g of x, we get 2 times 6 squared minus 1. Okay, so we get 6 squared is 36. So 2 times 36 is 72 minus 1, which is going to be did I do something wrong? No, we're good. Which is 71. And now I'm going to plug in 71 into here, so we're going to get square root of 71 plus 10 and then plus 2. Okay, so I'm replacing this x here with 71. Okay, and so now I have the square root of 81 plus 2. And square root of 81 is 9. 9 plus 2 is 11. Okay, we got the output that we wanted, didn't we? Okay, so I don't need to bother with this one here. And so when we have this first, what order goes first? This says we have g of x comes first, then f of x comes second. Okay, there we go.